Hello, I'm Robert Washer, and this is my Milestone 2 Animation Converter Animation Engine demo. Alright, here we have this test folder, which is in my under my Animation Converter. This is where I do all my converting for the animation from the FBX converter and put it into my custom runtime format. Alright, here we have 4 scripts. Clean me, which removes all the text documents. You have delete ROB files, which deletes my custom format runtime files. You have a copy viewer, which copies the ROB files over to the engine over here. And then you have the convert model, which actually runs the conversion. I'm going to open this up just to show what my command line argument is. Alright, it's a very simple command line argument. It's basically just FBX Anim Converter. You got the FBX file, and then the name, the base of the output file without any file extensions. And I'm just putting that to a text file. And then you call vodka on it, wrapping it up into. This is what comes out of the FBX converter. This is what the file will end up coming out as. Deletes any binary files that are created, and then it picks up any chunks, which is, in this case it's just 1, and then puts that into my custom runtime format. And so here we have the Teddy converter, Teddy format, and here we have the humanoid conversion. And it's very simple. It's a very simple conversion. Alright, going back here, I'm gonna run the conversion. Alright, it's creating Teddy, now it's creating the humanoid. And you can see now we have the custom runtime formats for Teddy and humanoid, as well as the text files that show just the output that I've generated in my process. And then I can copy these over, but just for that I have them here to show that I'm not just having some random other format here. I'll remove these from the engine, and then copy them back, and they're back. And then I'll just clean up this folder here. And before we get into the engine, I'm going to go through what my process was for the conversion. In main, didn't do a whole lot. I just do very minimum command line argument command line argument processing. I grab the I create the file output file name and basically just set up the stuff for it, and then basically otherwise it's basically just kind of the same format that was already found in the FBX converter before. I just got rid of some of the information I didn't need, and then in the global settings, display global time, I grab the frame rate and store that in my header, and then in hierarchy I loop through all the nodes, and starting at the root I go traverse the tree and call this call my custom display hierarchy ROB function, which goes in it if it's marked as a lim node, it creates the hierarchy data, which is just what index it is, the index of the parent, which is passed in here, which is passed in, and the name that is provided in the node. And then it pushes that to the vector of hierarchy data, and then increases the counts for that, and then calls it on all the children. And it just goes through and creates basically the tree structure that we need to be able to display the skeletons and animation in our engine. And then over in display animation, I'm basically filling up 2 vectors, one of ints, that's just what frames the time of each frame just as an int value, and then the data that's in that keyframe, which is just the data for one bone in one keyframe. It's a large vector of all the bones in the keyframe. Basically, first off, I grab the rest of the information for the anim header, and then I write that to the file. And then I write the hierarchy data to a file, that's what's next in my format. And then I loop through each of the animation stacks. And then call display animation here. I clear the data so that each stack has a fresh set, and you're not getting, so you don't have 2 keyframes at time 0, etc. This way you have them separate for each animation stack. It goes through for each stack it calls these display animation calls. It just goes down here. It does some little housekeeping to set stuff up. And it gets the layer. It gets the time span to get the max number of frames, and loops through. Right now I'm just grabbing one each frame, and then I'm pushing that int value as into my times vector, which holds all the times, and calling my custom format display animation rob function, which goes, and if it's a lim node, it will display channels. We'll call it display channels rob, which basically just if there's data, it goes down here and just evaluates the local transform at that time, grabs the translation, scale, and rotation, puts that into the bone data transform, and pushes that to the vector. If there isn't data, I check to see if it's a dummy node. If it's a dummy node, I still get the local transform and process. If it isn't a dummy node, I just fill it with blank transform data with a scale of 1, no rotation, no translation. And then I push that into the data vector. After looping through each one for that frame, I go back, get the next time, and do the same thing over again until I reach max frames. I create the animation header for that specific animation, which holds the number of frames, the max frame, total size, and a name. And I print out. I write all the times data to the file. I write the header to the file. Then the times data, and then all the bone data transform data. And that is basically, and it goes through that for each animation stack. That's basically what the converter does. And here are the headers, which is the animation header, which is the big header that's for the animation file, which has the number of animations, the number of bones, the frame rate, and the name. The hierarchy data, it just has an index, parent index, and a name. Then for each individual animation, it has the number of keyframes, the max time, total size, and a name. And here's the bone transformation data, which it just has translation data, rotation, and scale. I'm going over to my engine, to my loader. I basically read in the headers, my loader. This one's a bit more. Read in the header, read in both headers. I read in the animation file. I get the hierarchy data, and I set it up a skeleton for that, which is option. This basically sets skeleton data for a skeleton, and it basically just loops that hierarchy data, grabs the data, and basically sets the it inserts the data to the right, sets some basic data for the actual bone, like its graphics object. So it creates a bone and inserts it as a child of its parent as specified by its parent index based on its index. Basically, this is just creating a large basically creates all the bones in the thing in the correct hierarchy order. And then after it creates a skeleton, it loops through the number of IDs specified in the loader. So if you'd specify less than the total number of animations in the loader, it'll just take the first n number that you specify of individual animations. Goes through it, loads it up, and creates a bonated trans data array, and it reads also the times, creates an array of ints for the times, and then it creates a new animation and adds it to the animation manager. And creating the new animation, it basically sets up some basic data. It creates a result keyframe that holds the results of each slurp or lerp for the result of that animation at that time when it's processing. And then it goes through and just creates all, and it reads in all the data from the data that you read in from the file. Creates a keyframe data, which is a node basically that just has a next previous and the frames and all the bone data. There's a time. It has the next previous, and it has an array of bone transforms, which is basically all the scale, translate, and rotate that was in from the file. It loops to that, and then sets up the initial bone pose, which just goes through the tree of all the bones and sets up what its position is for that specific at time 0 for that animation. And let's just fire this up so you can see what it is. Alright, we got two animations running right now. We have the teddy bear walking right now, and we have the humanoid running across the screen. And we can pause. I think the teddy is right now paused. We can zoom. We can go backwards. We can go forwards. We can change the animation to the other one. So now it's an idle animation for the teddy bear, and I can change it for the humanoid too. Now it's in the punch animation, and I can pause that, start playing it, reverse it, back, pause it again, zoom. I can make it go faster, make it go slower, and even get a closer look at the humanoid. Go super fast. Go slow it down again. Go super slow. And then reverse. Reverse it again. Pause, zoom, reverse. And that's basically all the controls. You have, and take a close look at the teddy if you want. Here we have it idling, I have it walking, pause it, pause it, zoom, go backwards, forwards, go faster and slower. And that is my animation engine. Thank you.